Afternoon, everybody. Jeff Turner, Sales Channel Manager for Polypropylene here at McElroy, and we've got another great webinar for you today. Today, we're going to tackle that difficult task of vertical fusion. It's going to be broken down into 3 different segments. Robbie and Anthony are here to show you how it's done. So make sure you take notes. If you have any questions, don't hesitate to enter them down in the function below, and as we get to the end, we'll answer those questions for you. Again, it's Vertical Fusion Day here at McElroy. Robbie, Anthony, take it over.
Hi everyone, my name is Anthony Alvarez. I'm here with Robbie Phillips Jr. and today we're going to be covering vertical fusion. As you can see, we've got our vertical fusion stand sitting here right behind me. We've got our Acrobat 160 hooked up to it, our heater, our facer, and of course our DataLogger 7 with the EP800 HPU hooked up to it. Robbie, today we're going to be covering vertical fusion, right? How many different versions of vertical fusion are there?
Yeah, so you're going to have about 3 different versions of vertical fusion.
Absolutely. We've got 3 different versions that we're going to cover, and you can see right here on our stand, we're going to cover vertical fusion with the movable pipe below, which is going to be our first orientation here, and then we're going to cover vertical fusion with the movable pipe above with positive fusion pressure, and then vertical fusion with the movable pipe above with negative fusion pressure. Most of the time when we get the call in from the field, most of the time it has to do with that third application, that negative fusion pressure. Robbie, why do people call in for that negative fusion pressure when they're out there in the field?
Yeah, compared to a typical horizontal fusion, it's going to be the most advanced way to fuse that. You're going to use the HPU in such a different way that it does kind of become a different practice, but it's not all too hard as we're about to see.
Right, yeah. That third application with that movable pipe above and negative drag, I kind of like to think of it like a good, better, best scenario, right? We're going to start off showing you guys your best scenario, then the better and the best, just by going up overhead. So let's hop into it. I'm going to move back here behind the EP800 AD, and then Robbie, I'm going to have you work the heater and the facer for me as we go throughout the process here, and then we're just going to start fusing up some pipe.
All right.
Okay? So the first thing we're going to do, come over to our HPU. We've got everything zeroed out, so we have no pressure on our hydraulic power unit right now. Our facer is hooked up. We are going to leave our heater cold just so we're not going to have to bring in multiple new pieces of pipe throughout this demonstration. So if you don't see the pipe heating up and actually fusing together, don't worry, that's okay. What we're here to focus on mainly is the application of the HPU and the different ways we're going to operate it once we start putting different weights onto those pieces of pipe. You might notice that down here at Robbie's feet, we've got some weights. We're going to apply those to the apparatus here to simulate lengths of pipe, either on the bottom or the top of that fusion carriage, to simulate different weights and pressures pushing down into our fusion zone. So the first thing we're going to do, Robbie, I'll help you out here. We're going to get these weights onto the bottom half of our bottom piece of pipe here to simulate our first situation, which is going to be movable pipe below. And these green plates are going to be about 75 pounds each. So we're going to be simulating roughly, once we put 2 of these on here, we're going to be simulating roughly 2 to 3 pieces of pipe on the bottom half of this carriage. Pin those in so it's nice and safe. Okay. And now, like I said, we're simulating about 2 to 3 sticks of pipe going down here. Think of yourself, pipe chase, elevator shaft, wherever you might be where you've got some long lengths of pipe going up and down. This is where that application is going to come into play. So let me come back over here to our EP800 AD, and we're going to start going through the fusion process. Of course, I've got my DataLogger 7 hooked up. That's going to help us out as we go throughout the process, okay? Once again, that's got the guided workflow built into it. That's going to help us go down the way of making our fusion, okay? Main thing that we want to focus on here as we go throughout it is we're going to focus on that drag measurement and then that fusion graph that you get at the end. Really, that quality assurance, that's what everyone's after, right? And that's really applicable here, especially during a vertical fusion, because these are going to be some of the most challenging fusions that you do out there in the field, and you definitely want to make sure that you have the quality assurance that comes along with those vertical fusions, okay? So first thing we'll do, I'll come over to the DataLogger here, flip it around so I can get a better view of it. and then we're going to start going through the steps here. So I'm just going to go click the green start button. I've got all my information preloaded into the DataLogger, so we're not going to have to sit here watch me type it all in. So I've got all my job summary info typed in, the proper specifications selected, set up photos, weather conditions, pipe settings, and then that's going to get us all the way to our drag measurement screen, which of course we haven't done just yet because we're not there yet. So Robbie, what's the first thing we have to do in any pipe fusion, whether it's vertical, left or right? What's the first thing we got to do?
Yeah, in most cases, you need to be facing first.
That's right. So we're going to grab our facer that's right down by Robbie's feet there. We're going to install it into the machine. And one of the things that you're going to have to do additionally whenever you're doing a vertical fusion is you're actually going to have to support that facer, kind of like you see Robbie there. That way you can ensure that that facer is staying level inside of that fusion zone the entire time that you're going to face off. Okay, so all I'm going to do is come over to my HPU, click up into the facing pressure PR valve, and then I'm going to close my HPU here. You notice that nothing has moved, right? Because I have to go ahead and start increasing that pressure until I see that pipe start to come up. All right. So Robbie, if you can go ahead and turn on the facer here. Now I'm just going to slowly start dialing up the pressure until that carriage starts coming up and we start facing off the pipe. No need to rush this measurement. We're slowly bringing it up until the carriage starts coming up and in, and then we're going to start facing off pipe. Okay. So once we get it, Robbie's good to go ahead and turn off his facer. And then I'll open up the carriage here, and that will give him room to pull it out. One thing that we're going to do, once that facer comes out of the machine, is we're actually going to close it back up here because we want to make sure that we have our alignment, right? We want to make sure everything's where it should be. So we're going to go ahead, close it up, and then we can check our alignment. Using your DataLogger, you can use this to go in there. You can take a picture of your alignment, make sure everything's square and you're within specification for everything that's involved in that step. Okay, so we're good there. I'm going to open it back up. Okay, just a few inches here. And just like we normally do, we'll kind of start right there, 3-4 inches apart when we're going to start measuring drag. Is we're going to do that under what position in the manifold block, Robbie? What position we're going to measure our drag in?
Heating.
We're going to measure that under our heating pressure, right? So I can flip down to the middle there, and then I'll close the carriage. You notice when I went from facing to heat, and then I closed the carriage, the weight pulled that carriage back open, right? That's because all that weight is enough to push all that fluid back into the HPU here, and it's enough to pull that carriage back open. So all I'm going to do is I'm going to start dialing up my heating PR valve here until that carriage starts barely moving up. Unlike what we're used to seeing traditionally, where you barely get that carriage moving and get it to a stop, we're going to get that carriage moving and we're going to keep it moving up at a very slow pace, just so we can accommodate for that heater going in the machine. And once that heater starts melting that bottom pipe, we don't want it pulling away from that upper pipe. So you'll kind of see what I'm getting at here in a moment once we get this carriage in motion. But what we're going to do is just get it moving close at a decent pace here. So once again, I'm in heating PR valve, I'm in close, and I'm just slowly dialing up the pressure until I see that carriage start moving. And this can take you 30, 45 seconds, could take you a minute, could take you 1 or 2 tries to get it exactly where you want it. That's okay, because once again, if you're doing a situation like this on a job site, you might have 2, 3 of these fusions tops. These are going to be your tie-ins that you're doing, so there's no need to rush it. Get your drag measurement right where you want it. Make sure it's nice and precise. So you can see there the carriage has a good positive motion moving forward. That's going to be enough to accommodate for that heater melting down into that bottom pipe. So with that additional movement forward, it's going to keep both of those pipe ends nice and seated up against that heater plate. Okay, so we measured our drag here on the DataLogger. You can see that on the screen. And once we hit the next button, that's going to be where it tells us our fusion pressure. So we're going to go down to fusion pressure. Once again, I've got 0 pressure on there, so the weight was enough to pull it down. I'm in fusion. I'm going to close the carriage, and I'm going to dial up my pressure to 370 PSI. Okay? So all we're doing here is dialing up my fusion pressure all the way up to 370. Okay. So now we have our fusion pressure set. At this point, we've got our manifold block set up to where we want it. You can come in at this point. Once again, our heater's cold, so we're not going to actually measure any temperatures off of that and input it into the data logger, because we're mostly focusing on the functionality of the HPU along with the carriage and the differing weights. So what we're going to do is I'm going to open up the carriage here, and Robbie's going to insert the heater. And once he does that, we're going to start the actual fusion process. So he's going to get that in there. I'm going to hit the start fusion button, and then I'm going to be down in fusion, and I'm going to close the carriage up, and we're going to start the actual fusion process now. Robbie, what exactly are you going to be looking for? You know, if that heater was hot, what would you be getting off of both sides of that heater right now?
Yeah, so right now I'm looking for an indication of melt.
Looking for an indication of melt, right? Per the standard select, it's going to be about 1 millimeter. Okay, so once we see that, we're going to go in and we're actually going to reduce the pressure on our HPU here. That way, both the pipes are just resting on that heater. So, you know, once again, that millimeter of melt, depending on if it's hot or if it's cold, can come quicker, can be a little bit longer if the pipe's cold. We're going to say we've got that millimeter of melt now. So all I'm going to do to reduce the pressure and keep the pipe ends on that heater is come over to my HPU, and I'm going to click up 1 into the heating position, and I'm going to leave my selector in the closed direction. Okay? Reason being, that drag measurement that we measured earlier with the carriage barely moving forward was in the heating in the closed position. And essentially what that's doing right now is it's taking into account all of that weight that we have below and allowing that heater in there to just rest on each, or allow the pipes in there to rest on the heater nice and evenly. So we have 1:47 heat soak time for this. We're not going to have to wait here the whole time because once again our heater isn't actually hot. We're more focused on the process. So what we're actually going to do now is we're going to move into that open and close cycle. So what we have for this is going to be about 6 seconds to get it open, pull the heater out, and close it back up per the standard that we selected. Most of the time, you know, if this was in the field, I might be over here, and Robbie might be up in a pipe chase wherever it is, and I might not actually be able to see him, you know, with the carriage hooked up and everything like that. I'm running the controls here, and he's off. So make sure, you know, if you've got your 2 operators out there, that you've got a nice formed line of communication between you guys so you know exactly what's happening, because, you know, you only have 6 seconds to open it and get it back closed. So, Robbie, we're going to go ahead. I'm going to open up the carriage here in a moment. We're going to pull the heater out, and we're going to close it right back, and then that's going to complete our first iteration of the vertical fusion. So I'm going to go ahead. I'm going to open my carriage, just like so. Drop down to fusion pressure. Always want to make sure, you saw Robbie there giving it the pipe ends a nice inspection. Always make sure at this point that, you know, once that heater comes out of there, that those pipe ends are nice, flat, and glossy. You don't have any cupped appearance to them. Because once again, these are your tie-ins, right? These are going to be, you know, 1, maybe 2, 3 of these on a job site. Make sure that you do them right, because that drag measurement has become so much more important whenever you get into these vertical fusion applications, and you want to make sure it's just right. So that's why you saw Robbie put an emphasis on looking at those pipe ends when that heater came out of there. Same rules apply for fusing it together and cooling it down. Got a 9-minute, 40-second cool time. Make sure you go, you know, your full cool time on these joints, just like anything else. And at this point, once everything is fused together, you've waited your cool time, you're going to be good to take the carriage off and then move on to the next tie-in, whatever you happen to be doing on that job. Last thing before we do that, I'll come over to my data logger. I'm going to click done. I'm going to tell it that the joint's complete. I could leave any fusion notes. Robbie, what might be a good fusion note to leave on the data logger here for doing a big vertical tie-in like this?
Yeah, just any way to indicate this was a vertical tie-in, the specific location, any identifying information about this fusion.
Yeah, great point. I mean, this is a great thing to leave for the inspector so he knows, hey, this was one of those tie-ins. Might want to, you know, do your due diligence on these and make sure you take a good look at them. And then you can come in, of course, take any completion photos, make sure that your joint looks good, take a photo of it, that way you'll be able to identify it later. And then, of course, you get that joint report that we're all used to seeing with all the applicable information on there. Joint report looks pretty similar to just a left to right fusion on this. Only thing you're not really going to see is that once you do your reduction in pressure, your shift sequence, so to speak, you're not going to see that pressure slowly bleed off. It's just going to be that higher pressure that's going to stay in a straight line the whole time. Okay, that's going to be the only difference that you're really seeing on this one as compared to your traditional left to right, so to speak, fusion. All right. So let me hit the next button. That'll get us back to our home screen. And give me and Robbie a second here. We're going to take these weights off. We're going to flip the vertical fusion stand around, and we're going to get into our second iteration, which is going to be vertical fusion with a movable pipe above with positive fusion pressure. Now we're going to go through the second version of our vertical fusion, or second situation that you might find yourself in. This is going to be vertical fusion with the movable pipe above with a positive fusion pressure. Okay, this is going to be about 1 to 2 sticks above. That's going to be pushing down into your fusion zone that you're going to have to account for using the HPU here, and we're going to show you exactly how to do that. So just like on our first situation with the movable pipe below, we're still going to start with Robbie over here grabbing our facer, putting it into the machine, and we're going to start facing off our pipe. To do that, we're going to start up here in the facing PR valve, and I've got to open up the carriage so Robbie has a chance to get the facer actually in the machine. So I'm going to go into the facing in the open position, and I'm going to start dialing up the pressure just so it'll open up so Robbie has a chance to get that facer in there. So Robbie, whenever you're ready, go ahead and grab your facer, throw her in there, and then we are going to start facing off our pipe. Now you can do this one of two ways. Depending on how much actual weight you have above, you can slowly dial down the pressure, and if there's enough weight up there, it will push down the pipe into the facer, and you can use that to face off your pipe, kind of like you see there. Or if you don't have enough, you can click it back into the closed position. For ours, it looks like we have enough weight actually pushing down to face off the pipe, so I'm going to lift it up just a little bit, and then Robbie can go ahead and turn on our facer. Once again, he's supporting the weight of that facer, as you can see, and I'm just going to slowly dial down the pressure on our PR valve here until that top pipe starts coming down and starts facing off. Okay, once we get full ribbons coming off each side, Robbie's going to go ahead and turn off our facer. I'll lift up on the pipe. He's going to go ahead, pull that facer out of there, get it back in its stand. One thing that we didn't touch too much on that first one with the movable pipe below, make sure you're getting in here, you're grabbing all those shavings out of the way, because you can kind of see those Acrobat jaws. They've got some, they're machined out to make the machine lightweight and applicable in the field, easy to get it into this vertical application. So you make sure that you're getting all the shavings out of those machined pockets, so you don't have those coming back later and falling into your fusion and contaminating it later on down the road. While Robbie's pulling those shavings out and making sure our fusion area is clean, I'm going to get going on our DataLogger 7 here. Once again, I have a lot of our information pre-installed into the DL7 here. And we are going to skip on to our drag measurement screen here. Okay, I'm going to zero out my drag measurement because this one's going to be all new. And essentially what we're going to do, before we get to that drag measurement, I'm going to go ahead and dial down my pressure one more time in my facing PR valve just so we can check our alignment. Okay, just like so. Your pipe ends will come back together, and then obviously you want to get out there and make sure you're within the alignment of the applicable standard. At this point, I'm going to turn my facing pressure back up to a high pressure here, 300-400 PSI, just so we can use that later on during the open and close sequence during the fusion to actually get the heater out of the way in time. So now to measure our drag, we're going to do that in the following way. We're going to flip down to our heating PR valve, which I have all the way down here at 0. And I'm going to slowly dial up the pressure until I see the carriage start to raise the pipe. So I'm going to slowly dial that up till we see that pipe start to come up. Once again, I'm trying to open it up maybe 2-3 inches. Okay. And once I have that opened up, I'm going to slowly dial down my PR valve until the pipe starts sinking back in the other direction. Once again, this could take you 30-45 seconds, could take you twice to get it right where you want it. and that's okay. This is going to be a very important step. Another thing you want to account for, just like on that first one with the movable pipe below, is you want to keep that pipe sinking down at a little bit of speed there. That way, when the heater is melting into that bottom pipe, you're accounting for that with the top pipe moving into it. So I'm going to slowly dial down my pressure here until the pipe starts coming together. And then once it does start to come down, I'm going to look at my gauge on my HPU, because if you look at my DataLogger right now, it's reading that I have a 0 PSI on my drag measurement. Robbie, why is my DL7 telling me that I have 0 PSI for my drag measurement right now? I can see on my gauge that I have about 80 PSI on there.
Yeah, that's because of the way the hydraulic system is plumbed. The DataLogger 7 is actually only reading in the closed position. It's not reading your PSI in the open position, whereas the analog gauge is reading in the open position.
You're absolutely right, Robbie. As you can see right now, I'm in the open position, so I'm not reading anything on my DataLogger 7, but I am reading something on my gauge here. So I'm going to use that once I get this pipe moving down to my advantage, and that's actually going to be my drag measurement. So I'm going to keep dialing down the pressure. That looks pretty good right there. I would say we're probably right about 60 PSI for that drag measurement right there. So in the open position under heat, I've got about 60 PSI. Robbie, I've got my DataLogger 7 here. I didn't read a drag pressure on the screen, but it's telling me my fusion pressure is 111 PSI at 0 drag. So how do I come up with my fusion pressure for this fusion?
Yeah, so we're actually going to use our disadvantage to our advantage. We're going to take that negative drag and subtract that from our fusion pressure. 111 minus 60.
111 minus 60, right? So right about 50 PSI for that. So we'll go ahead and I'm going to come down to my HPU once again, down to fusion pressure to set that, and then we're going to close it, and then I'm going to dial that up to about 50 PSI roughly. Okay, once we get that dialed in, we'll have our HPU set up. So we've got our drag measurement locked in, we've got our fusion pressure where we want it, and we've got our facing pressure dialed up at that high pressure. So Robbie's going to be able to get that heater out of the machine once it's time to pull it out and get it back together for the fusion. So I'm going to hit the next button here. Going to get onto our start fusion page. So I'm going to open up the carriage a few inches so Robbie's going to be able to get in there. Okay, he's going to go ahead and insert our heater into the machine. I'm going to hit the start fusion button, and then I'm going to go down to fusion and close her on up. Okay, at this point you can see Robbie is still, he's got his hand under the handle of that heater. He's supporting the weight of that heater. That way it's nice and even in between those two pipe ends, and we're looking for the same thing we were on that first situation with the movable pipe below. We're looking for about 1 millimeter worth of melt coming off the pipe ends. Okay, Robbie's giving me the thumbs up. He said we've got that millimeter worth of melt. Now it's time to reduce the pressure on the pipe ends so that we're getting a nice even heat soak on them. And the way we're going to do that, we're going to flip into the open position here on our carriage selector, and then I'm going to flip up into the heating position. And what that's doing is under heating and open, it's taking that pressure and it's balancing that weight on the top side of that heater. So now everything is just resting on either side of the heater, and we don't have anything pushing on it, and we don't have anything pulling away. Real important on this one, once again, once Robbie goes to pull that heater out of there, that he gives those pipe ends a nice look, make sure that everything is nice, flat, and glossy. That's going to be an indication that you measured your drag correctly and that your fusion pressure is going to be where you want it. So once again, we don't have to wait the full heat soak time here because our heater isn't hot. So all we're going to do to open it up is I'm going to flip up to the facing position, right, where we put that high pressure into it. You're going to see the carriage raise up, just like that. Robbie pulls the heater out. He's looking at it to make sure it's good. And then I'll go back down to fusion, and I'll close the carriage, all right? Now, the reason we have to go down to fusion and close is because we still have that positive fusion pressure. That weight wasn't enough to offset us into that negative drag scenario, which is going to be our third and final one that we're going to do right after this. So let me hit the done button here on my DataLogger 7. Once again, with the Fusion notes, this is going to be a great time to leave the inspector whatever notes that you want to leave to help them, help build that case for that fusion joint on the job site. And then, of course, completion photos, use those to your advantage as well. Take a whole picture of your whole setup so he gets a great idea of what was going on during that vertical tie-in. And then, of course, you get your fusion graph here. This one is going to look pretty familiar, right? This one's going to be, it's going to look almost identical to that left to right fusion that you're used to doing. So I'm going to hit the next button. That'll take us back to the home screen. And now we're going to go on to our third and final situation with vertical fusion, which is going to be vertical fusion with the movable pipe above with negative fusion pressure. In this iteration, we're going to be doing the movable pipe above with negative fusion pressure. This is going to be where we have enough pipe above or on the movable side of our carriage that's going to be pushing down into our fusion zone. That's going to be actually enough to flip our fusion force to the negative side of things. This is the one we get the most calls about because it's going to impact the way you run the HPU the most. This is going to be roughly around 4, 5, 6 sticks of pipe above pushing down that you're actually going to have to offset that weight, and we're going to allow the weight of the pipe in this instance to fuse the pipe together instead of the pressure or the force from the HPU to fuse it together, if that makes sense. So throughout this whole process, we're actually going to have our HPU in the open position on our carriage the entire time, which is pretty unique. So once again, before we start going here, I'm going to go through my data logger and I'm going to skip through all the way to the portion where we're going to be on the drag measurement screen. And just like before in the first two situations, Robbie's going to grab my facer. I'm going to open up the carriage a little bit here for him. So I'm going to go to facing and I'm going to open the carriage here so he has room. Okay, so he's got his facer in there, and this is going to be, similar to the last one that we did with the movable pipe above. He's going to turn it on, and I'm just going to reduce the pressure on the PR valve until the weight of the pipe pushes it into the facer. So I'm just reducing the pressure so the pipe comes down, and then you can see just the weight of the pipe itself starts facing both sides. So, and if you're not getting ribbons, like on the top right now, we weren't getting any ribbons, reduce the pressure a little bit more, and you'll start taking off more pipe, okay? So be aware of what's going on. You can always reduce the pressure some more. So if you're bogging down the facer a whole lot, add some more pressure to it to offset the weight. So Robbie's giving me the thumbs up. I'm going to increase the pressure, and the pipe comes back up, and he's going to be able to remove the facer from the carriage itself. Okay, so once he pulls that out, he'll put it back in its stand. Same thing applies here. Before Robbie puts his hands in there, it's always a good idea. Put a good amount of pressure on this so it's got a lot supporting that weight above, because he is going to be putting his hands into a crush point there. So make sure that you have all that pressure holding up that pipe so it's nice and safe for him when he goes in there. So Robbie, I've got you all the way up at 600 PSI. You're going to be good to reach in there, grab what you need. And the same things apply. We want to make sure that area is nice and clean so we don't have any contaminants getting into the fusion zone and ruining one of our largest tie-ins potentially if this is going to be 4 or 5 sticks above that we're tying in. So we're getting in there, making sure everything's nice and clean. And once he does that, we're going to go in and we're actually going to check the alignment of both of our pipes. And we're going to do that just by reducing the pressure, and the pipes are going to come back together once I reduce enough pressure out of the unit. And then we're going to check our alignment and make sure we're within tolerance of the standard. Okay, so that looks pretty good there. The next thing we're going to have to do is we're going to have to measure our drag, right? So I'm going to go down to my heating PR valve. I'm in the open position once again. We're going to stay in the open the entire time. And then I'm going to go ahead and increase pressure in the heating PR valve until it opens up a few inches. Right about there, okay? And then we're going to do the same thing as we did last time. I'm going to reduce the pressure until the pipe starts to come down again, and then I'm going to look at that pressure right off my gauge. Once again, my data logger is still reading 0 because we're in the open position. Just like Robbie was talking about before, that's only going to read when we're in the closed position, and this whole operation is done in the open. Okay, so I'm going to keep decreasing the pressure until I start to see that movable pipe above start to come down into the fusion zone. And once it does that, I'm just going to look at my gauge here on my HPU, and then I'm going to read that. So right now we're at 200 PSI on the gauge. So on my DataLogger here, it's telling me we have a fusion pressure of 111 PSI with zero drag measured. So what I'm going to do is I'm actually going to take that 111 PSI and I'm going to subtract 200 from that, and that's going to give us a fusion pressure of negative 89 PSI, okay? So what we're going to have to do in order to set our fusion PR valve, once again, I'm not going to be able to do that on the DataLogger because I'm in the open position. I'll click down to the fusion pressure selector. I'm going to leave it in the open position, and then I'm going to dial up the pressure until it hits negative 89 PSI. And I'm doing that on the analog gauge on the HPU. Okay, so now we have our HPU set up with all of our PR valves, and now we're actually going to be ready to start the actual fusion process. So I'm going to open up the carriage so Robbie can get the heater in there. And I'm doing that using the facing PR valve. So I've got that dialed up to a nice high pressure once again. Okay, so Robbie's got the heater in. I click the start fusion button, and then I'm going to go down to fusion, and I'm going to leave that in the open position. So what we're doing right now is the weight of the pipe is providing the force needed to do the beat up on those two pieces of pipe so we can get our millimeter worth of melt coming off there. And we're in the open position and we're under fusion right now. So we're offsetting the weight of that pipe just enough to create our fusion force. And once we get that millimeter worth of melt, Robbie gives me the thumbs up. He says we've got it. So now I'm going to come back to the HPU and I'm going to click up into the heating PR valve. That's going to raise the pressure in my HPU all the way up to wherever we measured our drag at, roughly around 200 PSI, and that's offsetting more of that weight. So really that 200 PSI is creating just enough pressure in the system so the top pipe and the bottom pipe are just resting on that heater and they're heating up nice and evenly, all right? And once again, we're in the heating and we're in the open position and we're almost doing a little bit of a balancing act right here. So we're getting the top and the bottom pipe just to rest on that heater. Once we get through our heat soak time, which once again, our heater's cold, so we don't have to wait our full heat soak time on this, I'm going to click up into the fusion pressure, the fusion PR valve, and that's going to raise my carriage up, and then I'll click right back to my fusion PR valve all the way at the bottom, and then the weight of the pipe is going to force it back down and create the fusion force that we need. So I'm going to come up to the facing PR valve. You can see that it raises up the carriage. Robbie gives them a good look there, and then I drop back down to fusion, and the weight of the pipe itself brings it back together, and the weight of the pipe is actually creating the fusion force to fuse the two pieces of pipe together. We're not adding any positive pressure with this hydraulic power unit in the closed position. All we're doing is offsetting the weight of the pipe at different rates so we can achieve what we want by heating up and fusing the pipe back together. You also notice on our DataLogger report here, it's just the straight line across the bottom of the graph. As Robbie was talking about earlier, we were in the open position for the whole time. So that fusion graph that you're used to seeing go up, back down, and back up again, it's just going to be a straight line. So what you're going to get on this situation of fusion, you're not going to get that fusion graph that you're used to seeing, right? You're going to get the fusion notes, the completion photos, all that information that we input on the front end, the operator, any job site setup, your completion photos, your setup photos, all that stuff is going to be captured inside the DataLogger. You're just not going to get that fusion graph since we're in the open position for the entire fusion. And once I hit the next button, that's going to take us back to our home screen here. And at this point, we've got our pipe fused back together, and that's going to be how you're going to do movable pipe above with a negative fusion pressure.
Yep. All right, guys, thank you very much for joining us in our webinar today covering vertical fusion. I've got Jeff Turner with me here, Sales Channel Manager with McElroy, and we're ready to take any questions that may have come through throughout the webinar. And I think we've got we've got a few that are in the chat right now that are going to be shouted out to us. Jeff's going to repeat the question and then we'll answer it.
Thurman, what do we have?
First one says, in their first configuration, positive drag, how do you know that the weight of the iron is not enough to make the lower pipe start slowly sinking down during the heat zone?
So the question is, in the very first one, how do you know that the weight of the heater is not pushing down on the melt and too much weight for the pipe itself while it's going through the heat soak? I think I got that right.
I think so. Yeah. So great question. The way you know you're going to be, in the clear, so to speak, as far as that is concerned, is if you measure your drag properly, that carriage is always going to be slowly pulling that pipe up, taking away any of that, the heater melting down into the pipe, therefore not touching the top piece of pipe, if that makes sense. So with that drag measurement, like we explained in the video, and that carriage slowly creeping forward just a little bit more than you're used to, and like a side-to-side horizontal fusion, that's going to make up for that effect that was talked about in the question.
Good deal. What else we got, Thurman?
Next question, would these principles apply to HDPE with the Pitbull machines?
Okay, this question is, would these principles apply to the Pitbull machines with HDPE applications?
So another great question. If you're doing a vertical situation in HDPE and using a hydraulic manifold block, either like you could think like on a rolling 28 or one of the EP 1500s or EP 18 or EP 800s, any of those manifold blocks are going to work the exact same as we just showed you in the presentation.
Well, that HPU manifold, the whole hydraulic pressure unit's going to bring so much more consistency and control for you as opposed to trying to do that by hand. So
absolutely. Yeah, absolutely. Yeah. And the fact that, the McElroy EP800s, all of the hydraulic power units can meter pressure in an open position makes them that much more accurate and that much more better for a vertical fusion application.
And I say that by hand, like meaning like a 28.
Right.
Versus a 28 or a 14 or
right.
something like that.
Yeah. If you're doing a 14, 26, something like that, that's going to be a little bit different story because you don't have that hydraulic manifold block. All of the, all of the parameters or things that we touched on, the concepts all remain the same. You're just going to have to do it with something else, as far as, using the levers, things like that.
What else, Thurman?
Is this process the same with all McElroy fusion machines that use the hydraulic manifold block?
Is this process the same with all the McElroy fusion machines that have the same manifold block and HPU system?
Yeah, absolutely. Yeah, kind of like we touched on in the last question. If it's got that, 3-position manifold block, the traditional one you're used to seeing, whether it's the electronic style on the EP800 or like the traditional, rolling 28 manifold block, it's a little bit bigger. All the operation is going to be the exact same.
Yeah.
Can this process be completed with only the McCalc app?
Can this process be completed with only the McCalc app?
Yes. All you have to do, you kind of saw in the video there as we were doing different camera angles and things like that. You saw me have my calculator out on my phone. You can do it with just the McCalc app. You just have to know how to do those, simple subtraction problems when you're getting into the second and third positions and things like that. Yeah. So, as we would love for you to use the DataLogger, get all that quality assurance with it. But if you're out there in the field and you've just got the equipment, absolutely, you can do it with just the McCalc app.
And I guess theoretically you could do it by hand, doing the algebra to figure out the formula. If you did it without a calculator and without McCalc and without a DataLogger, you could do it that way if you knew the formula. I would highly recommend using technology.
The technology,
even if it's
a lot easier,
even if it's minimal and just the McCalc app. So, what else, Thurman?
Are there any other online resources we can refer to after this webinar on vertical fusion?
Are there any other online resources that we can refer them to, or they can refer themselves to for this type of?
Right. Yeah, absolutely. After these webinars, we usually take the recording of the video that we've done and we'll post it out there so everyone can gain access to it and then refer to it later. If you're going out and doing a vertical training, or if you're going out, and actually doing it on a job site, we want you to have that resource where you can actually see it and refer to it.
Yeah, maybe up for a limited time after this, but we're going to save this content for you guys so we have it for future uses. And obviously, this is a question that comes up quite a bit, which is why we selected it as one of our webinars for the quarter. What else, Thurman?
Are you going to do any more in 2024?
Any more of these? Yes, we actually are going to continue this series in 2024 quarterly. And if you have any suggestions, please don't hesitate to email us, text us. write it into the suggestions on the conversation chat here. We absolutely want to continue doing this. It helps us know what you guys are looking for content wise. And it also helps us create more content so we have more how-to videos out there that can show you guys, give you kind of a refresher when you're getting ready to go into an application.
Absolutely. Yeah. Keep your eyes out. We usually post out to, multiple social media platforms. And we also do, emails out before, a week, 2 weeks before the webinar actually comes out. So keep your eyes posted on social media and you'll see us promoting these and when the next one's going to be.
Yeah. And keep in mind too, these webinars and this content that we create for this particular for these particular sessions, this is not a replacement to become a qualified operator. Okay, this is not a replacement for your training to go out in the field. You need to work with your pipe manufacturer and McElroy to make sure that you're getting quality training to become a qualified operator. These are refreshers and help videos to show you that process. If you're already a qualified operator and have gone through those types of training, this is going to help you know what you need to do. And at the same time, you need to make sure that you go through that appropriate training, because this is not supposed to be a substitute for that hands-on experience for training.
Absolutely right, Jeff. What else, Thurman?
We got two left. Is this process also applicable with larger machines like the Acrobat 250, 315 Quick Fit?
Is this applicable? Is this? Can you do this with the 250, the 315, and the Quick Fit? That's the question.
Great question. Yes, yeah. As the machines get bigger, all of the the concepts remain the same. It's the pipe's just going to get bigger, the machine's going to get bigger. You're still using a McElroy hydraulic power unit with that 3-stage manifold block on it, and the process is going to be the same, just with bigger pipe.
And that's the consistency that we build into our HPUs, that we build into our line all across the board. And there are no additional accessories you have to purchase to accomplish this vertical fusion application, right? The HPUs are built to be able to do this without any additional accessories. So yes, the answer obviously is yes. And it's because of the HPU design that you can do that across the board.
Last one. What are some recommendations for best setup if I were wanting to train vertical fusion at my facility?
Okay, the question is, if I want to train vertical fusion at my facility, what's the best setup? Anthony?
Yeah, another great question from the audience. McElroy actually does make a vertical fusion stand. The one we were using in the video is actually a product that we make. And you can put your Acrobat 160, 250 right onto it, and you're able to train vertical fusion. It's kind of up to you to decide, however, to get the weight on there that you like. In the video, we just kind of had some mocked up weights and a piece of conduit going through the pipe, enough to keep it safe. For sure, you want to be safe because there is a lot of weight involved. But that's kind of up to the end user as far as how they want to apply the weight. But we do make a stand that holds the Acrobat 160, 215.
Yeah, it keeps it really simple, and it can fold up and store away nice and easy. And with just a few small pieces of pipe with weights like Anthony designed to add to that piece, it's a great way to show people that experience with vertical fusion. So Thurman, does that wrap up all our questions?
That's all the questions we've got today.
Wow, okay. Well, hey, we want to thank you guys for joining us for all of these webinars this year. Anthony's done a great job putting these together. Thank you, Robbie, to be a part of those. Jesse has been a part of them as well. And we'll continue to do this throughout the next year, 2024. And we will be at AHR. So if you plan to be at AHR, make sure you come by and see us and email us. We'll let you know what booth we're in. We want you guys to have a really happy holidays, have a great new year, and as always, reach out to us if you have any questions.
Absolutely. Thank you guys very much for joining us.
Thanks so much.